So I did some fine tuning with this neopixel audio circuit. So following up on the previous video, I had a little issue with noise from the amplifier, and a lot of it had to do with a speaker that I used to listen to the sound at the same time. And when I got rid of that, and I put some more capacitors and decoupling capacitors in, it seemed to work a lot better. So the background is, here's the neopixel driver circuit, which is basically a couple of 555 timers, some D flip-flops up here to sync everything, these two D flip-flops. I have some CD4017 counters, an AND gate, a single AND gate that I had to use, and I'll explain that why in a little bit. And a couple of 555 timers. I have this one 555 timer in the middle here that is our master clock, and I have a second one in monostable mode for the reset signal. That's it. These two I used to have for the high and low pulses, but they're no longer connected to anything, so they're just still on the breadboard because I don't feel like scrapping them yet. But anyway, that's the driver circuit. It is connected to these neopixels, which are now apparently audio responsive. And you can see what they're doing as I speak. And the way this circuit works, and you could sort of see it on the oscilloscope here. When I don't say anything or do anything, there's no signal. And when I say something, there's a signal. And so the way this circuit basically works is this is all, the sound is all coming from being picked up by this little electret condenser microphone. It's going through a high pass filter. And from the high pass filter, it goes into the input, the non-inverting gate, pin 3 of an LM386. This is basically an amp that is single rail power source. And basically the non-inverting input, pin 2, is going to ground. Power is coming from pin 6. Pin 4 is going to ground. And basically pin 5 is the output. Pin 7 is going through a capacitor to ground. And pin 8 and 1 are connected through a 100 microfarad electrolytic capacitor, and that is providing a large gain for the signal. The output is going through this 470 microfarad electrolytic capacitor, and from there it goes to through a resistor to ground. Well, there's a resistor to ground here. It's a 47 ohm resistor to ground. And the rest of it is going into the VCO pin, or the CV pin, control voltage pin, of which is pin 5 of a 555 timer. This 555 timer is wired to be in astable mode at a 1 kilohertz rate. And when the VCO with the audio signal comes into the CV pin here, basically what this does is it essentially makes the PWM so the duty cycle so small that it's essentially zero when there's nothing coming into it. And when there's something coming into it, it provides a duty cycle of very small duty cycle. I could demonstrate it there. The duty cycle is about 5%, a 5% and 95% minus duty cycle. And it happens to come in the exact frequency of the audio signal that's coming in. So when that is going to the input, D flip-flop of my neopixel driver, that neopixel driver essentially provides what I'm seeing on the oscilloscope here in visual form on the neopixel display, which you could see here. And basically, you know, it responds to frequencies fairly well, and it's, you know, it's all analog, the input signal that is, which is nice because I don't have to do any digital wave shaping or manipulation or anything like that. All I have to do is just put in an audio signal and it picks up very nicely with almost no noise. You know, there's a little noise that comes in occasionally through the circuit, but this is working fairly well. I've been at this now, this video has been going for 6 minutes and I haven't seen any noise. And this is all just me sitting about 1.5 feet away from this condenser microphone. So, you know, if I put my fingers in front of there, it responds very readily to that. And that's it. If I whistle, a little patriotic whistle, but otherwise came out pretty good. Anyway, I'm glad some people are enjoying this video. I've gotten some likes on the previous one. The next video I'm going to make is probably going to be the actual driver circuit itself. Thanks for watching.